Okay, so this lesson starts out with just going over the vocabulary that we just saw, which is nice. So part of like the homework on this is just going to be naming segments. There's also practice on this on Alex, and yeah, those are the questions that'll be on the test. So there's one question on the test that's just vocabulary. So here it says 1, name the circle. So when we name a circle, we name it by the center. So we'd say this is circle C, or like with the symbol circle C. Okay, next it says name 2 radii. Radii is plural for radius. So a radius would be from the center to the outside. So in this circle, it would be CD would be a radius, segment CD. Or you could also have segment AC would be a radius as well. Okay, we're going to stick with things we know for right now. The next thing is diameter. So diameter is when you go all the way across the circle through the center. It has to be through the center. So diameter would be this segment right here through the center, so it'd be AD. Okay, so now we're going to look at things that we haven't learned yet. It says name 2 chords. Okay, well, what is a chord? So over here, write down a little definition for chord. A chord is a segment with endpoints on the circle. It's a segment with endpoints on the circle. So what that looks like is it's either like 2 segments like this. It doesn't necessarily have to go through the center like diameter, but it could go through the center. Like technically the diameter is also a chord. So name 2 chords here. Well, it could be segment BH or segment AD. Colors. Then it says name a secant. Well, what is a secant? A secant is a line that intersects the circle at 2 points. Line that intersects a circle. And we aren't going to use this stuff down here, so if you want to use a space at 2 points. So a line that intersects a circle at 2 points. So for example, if you have a circle and it's just a line that intersects that circle at 2 points, like that. Oh, sorry. So an example here for secant would be KG. So this here would be a secant. Okay, and then number 6, name a tangent and a point of tangency. So just as a reminder, it's nice to have a definition here too. A tangent is a line that intersects a circle at 1 point. Line that intersects the circle at 1 point. So if we have a circle and a tangent line, it intersects at 1 point, and then this point of intersection is called the point of tangency. Point of tangency. So then name a tangency and a point of tangency. Right here, this would be a tangent line. It intersects at 1 point, so it'd be line GE. And then the point of tangency where it intersects is point F. Okay. Then from there, we're going to cross off these four and just skip to the next page. Okay. Then right here, let's start here. It says, tell whether segment AB is tangent to circle C. So in this example, if triangle ABC is a right triangle, then AB is tangent. Then segment AB is tangent. So if this is tangent, then it's perpendicular to that radius. If this is tangent, then it's perpendicular to that radius, etc. Like this should be 90 degrees, this should be 90 degrees, this should be 90 degrees. Okay, so how do we tell if that's a 90-degree angle? Well, we can use Pythagorean theorem. So we can use a squared plus b squared equals c squared. And if this works, then we have a right triangle, and that's a 90-degree angle. So setting this up, 6 squared plus 8 squared, is that equal to 10 squared? Does 100 equal 100? Yes. So AB is tangent. Okay, so now that we're going to test that out for number 12, this would be our A and B, our legs of the triangle, and then this would be our hypotenuse. So 9 squared plus 15 squared, is that equal to 18 squared? 9 squared would be 81, 15 squared, 225, 18 squared is 324. 81 plus 225 is 306. Does that equal 324? No. So therefore, AB is not tangent because that doesn't form a 90-degree angle. Okay, and then 13 and 14, we're not going to solve it all, but I want to show you that sometimes they won't tell you every little part of the segment. So here it shows that the radius here is 20, and it doesn't show you this part. So this part would be 20, and then this whole length would be 40. So you can always use what they give you to figure out other parts. Or like 14, it shows you this part is 8, but it doesn't show this part. Well, if the radius is 12, then this would be 12, because that would be the radius, and then the whole thing would be 20. Okay, and then moving down here, we're going to cross off these four, and then move over to the other side. Okay, so I'm down at the bottom of the other side, starting with number 23. This little arrow means it's a good one to go over. So for these examples, it says B and D are points of tangency, find the value of x. Well, when you have two tangent lines from the same external point, then these two lines are equal in length. So we can do 2x plus 7 equals 5x minus 8 and solve for x. To solve this, get all your x's on one side. Get all your constants on one side. 15 equals 3x. Divide by 3, divide by 3, we get x equals 5. And then we'll do one more example like this. They're all pretty much the same. 25, it says these are tangent lines. They're from the same external point, so therefore they're equal in length. So we can just set those equal and solve for x. Subtract 3x from both sides. We get x minus 7 equals 2, plus 7, x equals 9. Like that. Okay, and we will stop there. So your to-do list, and you should have a lot of time to get this done, is your homework 10-1 on Schoology. And then start your weekly Alex. And if you have questions on Alex, please let me know so I can help you get those done and accurately. Okay, go ahead and grab a laptop, get logged in. Let me know if you have questions.